Welcome to our deep dive. The date is December 4th, 2025. And today, the world of artificial intelligence feels like it's graduating. We're moving past just creating smarter models.
We really are. It's about aggressively turning them into industrial-grade assets. The theme today, looking across all our sources, is a kind of AI nationalism.
AI nationalism. So what does that mean in practice?
It's a relentless push to secure the core infrastructure, to optimize the whole expensive process of deployment, and to scale these models into reliable industrial engines. We're really in the era of AI engineering.
Okay, that's a great frame. So let's unpack that, starting where it all begins.
Yeah.
The model frontier. Segment A. We're seeing some huge advances in how AI learns to interact with the world and, maybe even more importantly, how it manages its own memory.
Exactly. And let's start with the body part of that. Google DeepMind just unveiled something called Sima 2.
Right, and this is a generalist embodied agent. So for anyone listening, what does that actually mean, an embodied agent?
It means the AI isn't just learning from text. It's learning by acting inside 3D virtual worlds. It sort of gets its own digital body. This new one is powered by a Gemini flashlight model, and it's all about autonomous skill acquisition.
And the metric here is what really stands out.
It is. The capability leap is huge. Sima 2 basically doubles the task success rate of its predecessor, Sima 1. And crucially, it can generalize those skills to commercial games it has never seen before.
So that doubling of the success rate,
Right.
it shows these agents are maturing incredibly fast.
Right. So that's the body. But now let's talk about the brain, because Google Research is tackling probably the single biggest headache in LLMs right now, memory.
The context window limit.
The context window limit, and what they call catastrophic forgetting, the fact that models just forget what you told them yesterday. This new research unveils the Titans architecture and a framework called Me9Rs for true long-term memory.
So how does it work?
Well, instead of being a stateless processor, which is what current models are, this new architecture actively updates a core memory module. It lets the AI learn and retain information during a conversation.
That seems like a fundamental shift. We're moving from a stateless tool you use once to, I guess, a stateful companion that remembers you.
That's the goal, a lifelong collaborator. Of course, that brings up all sorts of privacy questions, but it's the necessary trade-off for a truly useful digital assistant.
Okay, let's pivot now to multimodal generation and a major development coming out of China. Alibaba Group presented something called Live Avatar.
This is a really intense example of algorithm and system co-design. It's a huge 14 billion parameter diffusion model for creating real-time, audio-driven avatars.
But the real magic is in the infrastructure, isn't it?
It is. It's a technique they call time-step forcing pipeline parallelism, or TPP. You can just think of it as a way to make sure the generated video is perfectly smooth, it kills the latency and the flicker you usually see.
And the performance is state-of-the-art. It's achieving 20 frames per second on just 5 H800 GPUs. That kind of efficiency really underscores China's strength in this area.
For sure. And one last thing for research, which feels very necessary right now. If we're building all these agents, we need to make sure they work together safely.
A new framework for ethical multi-agent large language model systems.
Exactly. It's about putting in verification mechanisms to stop these multi-agent systems from developing emergent behaviors that, violate ethical boundaries. It's critical infrastructure if you want to deploy these things in high-stakes areas like, say, a hospital.
That idea of structural infrastructure is the perfect bridge to segment B, what's actually hitting the market today. And we'll start with Google's latest shot in the reasoning arms race.
Right. Google launched Gemini 3 DeepThink mode. It's for their Ultra subscribers, and it's Gemini's most advanced reasoning mode yet.
How does it work?
It uses iterative rounds of reasoning, so it explores multiple hypotheses at the same time to solve really complex math, science, and logic problems.
And the metric to watch here is its performance on the humanities last exam benchmark.
It scored 41%, which is a really meaningful improvement. This is a direct escalation in that premium reasoning race. It's for users who absolutely need reliability for tough intellectual work.
Speaking of reliability in the enterprise, AWS just made a huge move.
They did. They're cementing their strategy. They're moving away from, the simple chatbots and going all in on continuous automation. They unveiled the Nova 2 model family and 3 new frontier agents.
Agents for security for DevOps.
Right, and a general one called Kiro. And the key thing here is they are designed for autonomous operation over extended periods. This is not a chatbot you talk to for 5 minutes.
So AWS is betting that the next trillion-dollar market isn't in chat, but in asynchronous, long-horizon workflow automation that just runs in the background.
That's exactly it. They're selling automated operational management, not a new chat interface.
And not to be left out, Google is pushing its models deeper into the Office workflow too.
Yeah.
Full Gemini integration across Gmail and Workspace.
This is a big one for productivity. It can summarize those ridiculously long email threads, draft really polished replies, find anything across your Google Drive instantly.
It basically turns your inbox from a chore into a command center.
Exactly, a proper workflow tool. Now, before we get to the hardware, we have to talk about the software layer that makes it all run. NVIDIA released CUDA 13.1.
And the big headline there is the new CUDA tile instruction set.
Right. CUDA Tile is a new virtual instruction set, and what it does is it abstracts away the complexity of managing tensor cores. It just makes it much, much easier for developers to program these massively parallel chips.
And easier means more efficient.
Way more efficient. The benchmarks show a 10-fold performance improvement for running these big Chinese mixture of experts models, or MOE models, on their GB200 platform.
That's a huge jump.
It is, and it's also a subtle geopolitical move. MOE models are very efficient, which makes them popular with Chinese firms that face hardware constraints. By optimizing CUT for them, NVIDIA reinforces its software moat everywhere, even as the hardware competition heats up.
That sets us up perfectly for segment C, where that theme you mentioned, AI nationalism, becomes very, very physical. This is all about infrastructure.
And we'll start in the U.S. The Department of Energy launched a historic initiative they're calling the Genesis Mission.
It sounds big.
It is. It's a massive, coordinated mobilization of all 17 national labs, academia, and private industry. The whole goal is to accelerate scientific discovery using supercomputing and AI.
And what's the stated objective?
To double the productivity and impact of American science and engineering within a decade. It's a signal that the U.S. government now sees AI compute as a sovereign capability, like roads or the power grid.
Meanwhile, in China, the push is for self-sufficiency.
A huge push. China's CameraCon is aiming to triple its domestic AI chip output in 2026. They want to fill the void left by U.S. export controls on NVIDIA and compete head-on with Huawei.
The goal is to deliver 500,000 AI accelerators next year. But there's a catch, isn't there?
A big one. Ambition is meeting physics. Their current manufacturing yields for their most advanced chips are estimated at only 20%.
Wow, just 20%.
That number really highlights the fundamental manufacturing bottleneck they are facing. It's a massive challenge.
And the bottlenecks aren't just the main processors, it's the memory, too. SK Hynix just announced a major restructure.
They're creating a dedicated high-bandwidth memory, or HBM, task force in the Americas. HBM is that super-fast memory stacked right on the GPU. Without it, the whole system grinds to a halt.
So a shortage of HBM basically stalls the production of all next-gen AI accelerators.
Exactly. This move from SK Hynix shows that memory bandwidth is now the critical constraint, and they are reorganizing their entire company just to try and solve it.
And finally, on the infra front, we're seeing a huge bet on an alternative to NVIDIA. Volter and AMD are deploying a massive supercluster in Ohio.
A 24,000 GPU AI supercluster, all powered by AMD Instinct MI355X GPUs. It's an investment of over $1 billion.
That feels like a major validation for AMD.
It's huge for them. It proves they can move a massive volume of accelerators and that there's a real competitive market outside of the NVIDIA ecosystem.
Okay, that competitive hardware landscape leads us straight into segment D policy and governance. And it seems like global approaches are really starting to diverge.
They are. In the U.S., the political pressure is intensifying. Senators just introduced the SAFE Act to codify the China chip export ban.
So this would make the current temporary restrictions permanent law.
For at least 30 months, yes. If it passes, it would order the Commerce Department to halt export licenses for advanced AI chips to both China and Russia, which would obviously have a massive impact on NVIDIA and AMD's revenue.
Okay, well, in the EU, the focus is less on supply chains and more on market power.
Exactly. The EU has opened an antitrust probe into Meta's WhatsApp AI chatbot policy.
What's the issue there?
Meta has a new policy that bans third-party AI chatbots from using the WhatsApp Business API. The EU is investigating whether that's an abuse of their market dominance to stifle competition.
And then you have a third path emerging in Asia. India released its national AI governance guidelines today.
Right. And they're striking a different tone. The focus is on risk classification and data governance, but with a very strong emphasis on balancing that with innovation.
So it's a more pro-innovation approach than, say, the EU's stricter framework.
Much more. It really formalizes India's distinct path. But despite all this policy talk, there's one issue that keeps coming up: safety.
The Winter AI Safety Index report came out, and the findings are not great.
Not great at all. It was an independent evaluation of 8 leading AI companies, and none of them scored above a C+. The report cited a core structural weakness in safety across the board.
And the most critical finding:
Not one of the 8 companies presented an explicit public plan for how they would control a superintelligent AI. It really reinforces the need for mandatory safety standards as these systems get more and more powerful.
this idea of structural weakness is a good pivot to our last segment, Segment E, which looks at corporate spending and strategy.
And we'll start with OpenAI, which just made a very strategic acquisition. They bought an MLOps startup called Neptune.ai.
And MLOps is machine learning operations. So this is about strengthening their training infrastructure.
Precisely. Neptune is a platform for tracking, analyzing, and debugging AI model training experiments. OpenAI is integrating it directly into their internal workflow.
And the deal, it was under $400 million. So this isn't a massive acquisition, but it's very telling.
It's a perfect signal of industrial maturity. The most expensive part of AI isn't just buying the chips, it's the wasted GPU time from failed or inefficient training runs. They are spending almost $500 million just to get more operational control and lower their GPU costs.
That's a really sharp insight. Now, on the enterprise front, a massive partnership: Snowflake and Anthropic.
A $200 million strategic partnership. This deal integrates Anthropic's Claude models directly into Snowflake Cortex AI.
Which means Snowflake's enterprise customers can build AI apps using their own data securely inside the Snowflake Data Cloud.
And that $200 million commitment, it positions Claude as the go-to provider for production-ready, highly governed reasoning for Snowflake's, 12,000 plus enterprise customers. It's all about security and governance for big corporations.
And finally, maybe the biggest signal of all about where corporate priorities are right now: a major pivot at Meta.
A huge pivot. Mark Zuckerberg is considering cutting the budget for Reality Labs, their whole metaverse effort, by up to 30%.
To do what?
To prioritize AI investment. It's the clearest signal you could ask for. It shows a global consensus that the immediate competitive need for AI now completely overrides these more speculative long-term ventures. AI is the only game in town.
Okay, let's wrap this deep dive with some actionable takeaways. First up, the tools you can actually use today.
So if you work in machine learning, check out the Hugging Face HFLMM Trainer skill. It's a tool that lets you use natural language to tell Anthropic's Claude to just orchestrate an entire machine learning workflow.
So select the hardware, write the training scripts, everything.
It automates the whole MLOps process. It's incredibly powerful.
And a reminder for Google AI Ultra subscribers that Gemini 3 Deep Think mode is now live for tackling those complex reasoning problems.
Now for the numbers of the day. Number 1, $161 billion.
That's the amount of global venture funding that went into the AI sector in just the last 9 months.
It represents 64% of all venture funding globally. That concentration of capital is what's driving this incredible pace.
And number 2, which brings us back to that geopolitical bottleneck we talked about, 20%.
That's the current estimated production yield for Cambricon's most advanced AI chips in China. It's a stark reminder of the huge manufacturing challenge they're facing, trying to compete with NVIDIA.
So when you pull it all together, what's the final takeaway from today?
It's that the industry has fully entered this phase of aggressive industrialization. The focus is no longer just on making the AI smarter. The breakthroughs are still happening, like with the Titan's memory architecture, but the real story is about how to build, govern, and mass-produce that intelligence in a very constrained world.
Which leaves us with the final question for you to think about. How is your own sector responding to this massive infrastructure arms race? Are you focused on raw performance, just buying the fastest chips, or are you optimizing the expensive process of development, like OpenAI did with that Neptune acquisition?
That distinction between performance and process really defines the leading edge of AI right now.
Thank you for joining us for this deep dive into the latest in AI. We'll catch you next time.